What are the internal mechanics of JavaScript tree shaking? Imagine building a big Lego set, but only using the pieces you really need. That's kind of what JavaScript tree shaking does for your code. It helps remove parts you don't use, making your website faster. When you bundle your JavaScript files, you want to keep the size small so pages load quickly. Tree shaking is a way to do that by getting rid of unused code. It mainly works with S modules, which are a special way of writing JavaScript using import and export statements. These modules are static, meaning their structure is fixed and can be analyzed without running the code. The first step in tree shaking is module resolution. The bundler looks at all the import and export statements to see which modules are connected. It figures out what depends on what. Next, the bundler creates an abstract syntax tree, or AST. Think of the AST as a detailed map of your code structure. It breaks down your code into functions, variables, classes, and imports or exports. This map helps the bundler see exactly what is there. Then, the bundler marks what code is used and what is not. It walks through the AST and notes which functions and variables are actually referenced somewhere in the code. Anything not marked as used is considered dead code. After that, the bundler removes all the dead code from the AST. This step is called dead code elimination. It's like trimming off the branches of a tree that aren't bearing fruit. Once the unnecessary parts are gone, the bundler converts the cleaned up AST back into JavaScript code. The result is a smaller, optimized bundle that only contains the code your application needs. Several factors influence how well tree shaking works. Because S modules use static syntax, the bundler can analyze dependencies at compile time without executing the code. This makes it easier to identify unused exports. Some modules might have side effects, which are actions that run just by importing them, like changing global variables. Bundlers use a side effects flag in the package metadata to decide if they can safely remove unused code from those modules. Sometimes, the bundler runs multiple passes over the AST. The first pass gathers all declarations, the second marks usage, and the last removes dead code. This process ensures accuracy. Tree shaking often works alongside other optimization techniques like module concatenation and minification. When combined, these methods produce a very small and fast bundle. For web developers, understanding how internal mechanics of tree shaking work means you can write code that is easier to optimize. Using S modules instead of older module systems like CommonJS makes a big difference. Also, avoiding side effects in your modules helps the bundler identify what can be safely removed. In the end, tree shaking is a smart way to keep your JavaScript lean and your websites quick to load.